Hi, everyone. Good morning, good afternoon. My name's Emma. Thank you for joining us for today's webinar with Concertio and Blazemeter on automating performance tuning of Kubernetes. Before I pass it over to our hosts for today, I just want to remind everyone that the webinar will be recorded and we'll be sending out the session in the coming days. Also, you have a question tab on your GoToWebinar panel. You are welcome to ask questions, type them in throughout the webinar, and we'll try and answer as many as we can at the end of the webinar. And whatever we don't answer, we'll be also trying to get back to you in the coming days. One last thing before I pass it over is at the end of the webinar, there'll be a very short survey that pops up. If you can take those 10 to 20 seconds to just answer that, it gives us feedback for our webinars, and you can suggest topics for future webinars so we can keep providing you with the great content and information that you'd love. And obviously you can ask for follow-up sessions as well. So I'm going to pass it over now to Dr. Tomer Morad from Concertio, and we also have Zina Takele, the performance engineer from Concertio, and Raphael from Blazemeter, who are joining us today. So thank you all for joining us, and please take it away.
Thank you so much, Emma. Hi, everybody. I'm Tomer from Concertio, co-founder and CEO, and with me from the company is Zina. He's our performance engineer. And thank you, Raphael and Emma, for hosting us in this webinar. And the reason, actually, that we are doing this webinar is performance testing is a big issue, an important issue when deploying production scale systems. And as users of Blazemeter, you know that you can use these high performance and accurate tools to make your systems better. Now, Concertio is all about optimization, and the coupling of performance testing tools together with performance optimization tools is something that is that fits like a glove. And this is what we want to present in this webinar. We're going to present some concepts of performance optimization and settings optimization using Optimizer Studio, which is the product of Concertio. So what we're going to do today, we're going to speak a little bit about the basics of static performance tuning and what it means. Then we're going to talk about how to create a load test for the purpose of performance tuning. Performance tuning requires loads that are a bit different than loads that are required for just performance testing, and we'll talk about that. Then we're going to prepare and run automatic optimization using Optimizer Studio, and we'll talk about how to prepare it. And then we'll do a bit of a live demo and show you some results of the optimization of a Kubernetes cluster. So a little bit of background. So computing systems have many tunable settings. You can find them in the processors, things like controlling the last level cache prefetchers of the CPU. You can toggle them. That unless you're an expert in CPUs, you don't even know that these settings exist. You have a lot of them in the firmware, like DVFS. In the operating systems, you have many, like Affinity, task scheduling, granularity, and others. In the application frameworks, you also have many, like Kubernetes. We're going to talk a bit about that. You can control there the resources that you allocate for each container. You have databases that have many database tunables. The applications themselves, think of all the defines in the applications. Even in the choice of compiler flags, you have many opportunities. Now, the idea is that if you tailor all of these settings to whatever you're running, you get significantly higher performance. Now, this is common engineering knowledge. And let's talk a bit about definition. What is a tunable? So in this webinar, when we refer to a tunable, it represents a setting that you can change programmatically using some kind of script. It affects the metric of interest. So if you're trying to improve performance, this tunable needs to somehow affect performance, whether to speed it up or to slow it down, and that it retains correctness. So you will still be able to do the same job, but with a slightly different configured system. Now, the tuning process is basically the process of finding the best setting of a set of knobs or tunables. And let's talk about a tuning example. Let's say you have one application and one tunable that can either be on or off. So how would you tune it? So the process is simple. You turn the knob on, then you run the application several times, then you turn the knob off, then you again run the application several times, and then you look at the results. And if one of the settings was statistically better than the other, then you conclude that you need to use that setting. So this is basically the process of tuning for one knob, and it gets, of course, complicated when you add more. And this is basically what happens. So it used to be easy to tune systems when you had only a handful of settings. A performance engineer would do this job. They would spend a few hours and they would tune the settings. Unfortunately, today it's impossible, because today we already have hundreds of settings, and these settings depend on each other. So the number of possibilities to configure a system today is enormous. We see numbers like 10 to the power of 40. It's not something you can go and run an exhaustive search on. Now, there are many practical challenges for manual tuning. First of all, there is a talent shortage. Not a lot of people know how to do this. And it's very hard to come by these people, because they need to be experts in many domains, all the way from the software to the hardware level. It's also time consuming, because it requires an iterative process of coming up with a configuration and testing and reporting the results. And companies need to really have focus on doing that. And it's also expensive, not in terms of the time, but the idea is that every time you commit a new version of your software, or you change the hardware even, the optimal point moves. So you have to retune. So it all becomes very expensive. So for this reason, yes.
I think that, you know, and the many practical challenges here, I think cloud and Kubernetes is the reason why most people are going for, right? It's like, hey, I have a talent shortage. Not everybody can be JVM, Oracle database, or NoSQL database, understanding hardware, spindle disk, and everything. So talent is a shortage. I really need to get things up and running, especially on startup method, right? And when I go to the cloud, then I just add more and more machines, hopefully, that to serve my customers, and that becomes expensive.
Yeah, that's absolutely correct. And to add on that, the ever-changing landscape. So now you have Kubernetes, and tomorrow you will have another technology, and it's very, very hard to keep up, to the point where you just give up. It's just too difficult to go and chase the optimal settings.
So it would be really cool if we could find the optimal settings and then automate it, and then just run it every time that we need to do a code change or an environment change, and get the best for what we need, and by that save money and time.
That's right. So if we could do this, for example, to implement this optimization within the CI/CD pipeline, then we can always get our software and hardware with the best settings, and we will not have to worry about optimization, and actually focus on more important things to do. So given that we don't have these systems today, or they're not widespread, most systems are not optimized for their workloads. And because the ROI is not there, the settings, it just remains at inefficient defaults. So let's look at the different stages of automatic optimization. So the first stage, and maybe this is the most difficult stage, and we will talk more in depth about it, is preparing your workload. Your workload needs to be denoised, it needs to be repeatable, and it needs to be fully automated. So this is the first step that you need to do in order to even think about automating this whole process of optimization. The next step is you need to choose what you want to optimize. So maybe you would like to minimize the average response time. Maybe you want to look at the 90th percentile. It's very important to choose the metric that is most important for your business. And we will also talk more in depth about the target metric. After that, in terms of settings optimization, you need to define or decide which settings you want to play with. Then you want the tool or some kind of automated tool to find their best setting. After that, you start the optimization process. You come up with this system configuration, which is basically a list of keys and values where key is a tunable and a value is the value of the tunable. And you test. You run it. You run the workload on the system of test, and you look at the results. And maybe you will keep it, or maybe you will run another test. This is an iterative process which takes a lot of time until you find a configuration that you are happy with. And when you do find it, then you report the results. So this is basically the optimization workflow. Now let's talk about how this can be automated. So Concertio has a tool called Optimizer Studio, which automates, fully automates the right part of this process. So in terms of coming up with the configuration, so the tool has an advanced optimization algorithm based on evolution algorithm or genetic algorithm to search the huge parameter space and come up with a good configuration with minimal steps. It also deals with noise and variability when measurements are, it's inevitable on real systems that you will have variability. So the tool knows how to do it. It knows how to denoise. It knows how to take enough measurements to be sure of the results. And of course, the reporting, this whole process, if you have done this in the past, you know that it's hard to keep track of all of the experiments that you have done in a good way. So everything is automated, and then you get a report with a full log of what has been tested. So this is Optimizer Studio, the full automation part. Another thing that the tool provides you with is tunables. So the Optimizer Studio has a library of supported tunables, such as Intel processor tunables, or MySQL database tunables, or Kubernetes tunables. But if something is not supported, you can easily add that to the tool in the configuration files. In terms of the optimization targets, so the tool supports targets that can be simple, such as the average response time, or can be complex with if statements. For example, I want to look only at results that the latency, the 90th percentile doesn't exceed, I don't know, half a second. So that can be more complex. And in terms of preparing the workload, then Concertio provides best practices and training for preparing loads for personal tuning. So this is the flow of optimization workflow. So let's talk about maybe the most difficult task when coming to automate performance tuning. This is how to prepare the load test. So the first thing that is very important is that you have a workload that is representative of the real world workload. So when possible, you should replay from production. Again, this is best practices. And when possible, you should run on similar infrastructure and software stack, because it really affects the performance. Using a tool like BlazeMeter, you can replay things from production very easily. You wanted to say something?
Yeah, just to jump on that, things that we can also do, for example, is we already have the business flows of that we develop, right? Because we have our load tests, for example, events like Black Friday or things that we're monitoring like synthetically with BlazeMeter or something like that. We can actually use those to take a decision on the performance of, let's say, something like our Oracle database, right? If we want to change it and see if something affects that, we can do that. But as you said here and pointed out, also replaying log can really help us identify the performance issue and then tune it. So if we know that we had an hour when we saw a spike, let's say we have an API backend, and we can just take all those requests and just replay them while we are tuning our backend, we can find the best configuration for that. And it's really easy because we already have the infrastructure in place to support the running of those tests. So you don't need to do an extra work for that.
Yeah, makes sense. And the next thing that is very, very important is that the load should be repeatable and fully automated. And what we mean by that is in the automation script, first of all, you have to clean up the environment before and after each run. Remember, you're running this workload in a loop. So it needs to run in the same manner again and again. And you need to restore the system state after each run. And if you have tunables, you need to be able to use those tunables in your workload script. Then the target metric, you need to be able to output some kind of target metric that interests you. And this target metric needs to exclude any time, or if it's measuring time, any time spent on the setup or the cleanup or the runtime effect, ramp-up effects. You want it to be a clean target metric that captures the steady state. And,
and that, Tomer, for example, also you want to make sure that you don't break some of your pass-fail criteria, for example, right? So technically, let's say you can do some performance for cost, right? You want to make sure that the cost is less, but by accident, you can break a pass-fail criteria that you already had in your test. So you want to, although it's a classic case of, surgery went okay, patient is dead. Like we got what we wanted, but the main goal was kind of missed because we didn't know about it. And if you set up those pass-fail criteria as part of your test, your performance test, for example, and you tune your production, you might get a very good tuning configuration, and you then verify the pass-fail criteria, and you can say, okay, that's not only just a very cost-effective tuning configuration, it also gets me the business goals that I need. I did not breach my, let's say, 1 second from home page on the 90th percentile response time.
Exactly. So the target metric needs to be very precise and very exact for what you're looking for. And if you already have load tests with these kinds of criteria, you can just port them to the test for the performance tuning. Another thing is that this also relates to repeatability. The test needs to be long enough to be meaningful. So the actual duration needs to be longer than all of the ramp up and the setup and the cleanup, because that will help with minimizing the variability. And speaking about the variability, we are now talking about a tool that can optimize and decide between two configurations or many configurations, which one is better. And if these signals are too noisy, the tool will not be able to make a decision. It can very easily make a wrong decision. So in order to feed the tool with good input, the input needs to be with low variability. So first of all, you have to denoise your environment. So if you have, let's say, a website running on VMs, perhaps for performance optimization, you might want to run that on bare metal just to take out the noisy neighbor effect, things like that. So
Yeah,
after you, yeah.
yeah, and it's important, like you can experience one of those five or all of them across your software development lifecycle. So for example, it can be on your production, and it can be on your staging or even on your integration test, integration environment. And another thing is that it can be on a different type of test. It can be on your, when you're running your build. So maybe you want to optimize your Jenkins, or maybe you're running soak tests or performance tests. With soak tests, for example, you are looking for memory leaks, right? And it might be that you need to run a soak test for like even a couple of days in order to do those things. How would you be able to do that? You'll need a new tool or something like that. And this is important when you have the platform in place to support those kind of things. All you need to do is just add the automation for the performance tuning of it, keep the business without any distraction, keep running the tests that you're doing, and while you're doing that, get the tuning done, and then you can go and kind of say, okay, hey, we were able to improve efficiency, either by throughput or by cost or both.
Yeah, and I wanted to add here another thing. You have variability in your system, but you also have variability in the applied load. So if you are applying a load and this load itself has variability, that is going to propagate to the results. So using BlazeMeter, for example, wherever you set your system, you will have BlazeMeter servers in the region of your system under test. And this is also something that lowers a lot the noise that you see in your system, and it makes it easier for a tool to make good decisions. On top of that, you need to perform sanity checks. So after you denoise the system, you should run your application without any change. Just run it several times from the command line. Look at the results, calculate the mean and the standard deviation of the target metric, and see if it really makes sense before you go to the next step, which will also be time consuming. And when you see that the variability is low, then you can proceed to the next step. So how do you decide on a target metric? So the target metric should represent what you want to optimize. Either you want to maximize it or to minimize it. So it can be a scalar value. This means, for example, you can look at the average response time or the 90th percentile response time in order to filter out some outliers. And you can also look, for example, at the cost per average response, which is a good proxy for the cost that your cluster will cost you. So in this case, you would just multiply the cost per time or per second, multiply by the average response time, and you will try to minimize it. And this can get, of course, more complex. You can take the time, and you can make it. You can take a square of it to have more impact for the time. It can also be a more complex objective, like a multi-objective optimization. So you say, if the 90th percentile average response time, sorry, the 90th percentile is above half a second, then we tag the target metric as invalid. So the tool will just skip it. Otherwise, we take the cost as we defined it above. And it could get more and more complex depending on the business needs. These are actually very simple rules. So the workflow of working with Optimizer Studio is, first, you need to have your workload script ready. You wrap it in a script that later the tool can invoke. You define the target metric. It can be a scalar, whatever it is. It's very easy to plug it into the tool. You then configure your tunables. So you either use the out-of-the-box tunables, or you define them yourself in the configuration file. Then you run the tool. It's all automatic, and at the end it gives you a recommendation, which is basically the best settings that were tested and found to increase or decrease the target metric as you define. And you also get a script that you can later go and apply all of these settings in production to get the better performance as you defined it. So in terms of the out-of-the-box tunables that the tool supports, the tool supports Intel CPU tunables like last level cache prefetchers, like energy bias, like other MSRs. The tool also supports Linux tunables, like I mentioned, that scheduling granularity and others. Kubernetes tunables, like the memory of a node or a number of CPUs for a node. We also support Hadoop cluster tunables and OpenMPI, that's in big data and HPC. Databases that are supported out of the box are MongoDB, Postgres, and MySQL. A bunch of web servers, PHP, Apache, HHVM, Mellanox network gear, and the GCC compiler flags. And we are constantly adding more and more libraries of tunables to this list. So here's a very simple example, a synthetic example. It's not even related to performance, just showing how the tool works and connects. So here we're trying to optimize the sum of A and B. So this is the workload script. We take two environment variables, A and B, we add them together, and we write the result into a temporary file. We then have a configuration file of Optimizer Studio. It defines two tunables. Notice that they have the same names. Each one of them can have two values, either 1 or 2. We then define a metric. Using a script, it reads the contents of this temporary file. It's called shell.target. And at the end, you can see this line, we try to maximize shell.target. So we're trying to maximize shell.target, which holds the contents of this temporary file, which holds the contents of A plus B by playing with A and B. So then we run it, and unsurprisingly, the values that maximize the target metric are A equals 2 and B equals 2, because 2 plus 2 is 4. So this simple example just shows how easy it is to connect any kind of workload to the optimization engine. So the tunables are passed through the environment, and the target metric is passed through a temporary file, and all the rest that happens here in the script is specific to the environment of the user. So this, I will just mention here one more thing about the algorithm. So this is called the black box optimization algorithm. So Optimizer Studio does not know anything about the inner workings of the workload. It just knows the tunables that it can play with, and it sees the result, and it learns everything it needs to learn from the result. So this is what we are trying to optimize with Kubernetes. So we have a Kubernetes cluster on Google Cloud. In the cluster, we have a load balancer that balances loads. And here we have the web server. This is a web server that runs on Linux, Apache web server with PHP, and on top of that, Magento. And it also has another pod with MySQL running on Ubuntu Linux. So we're trying to optimize, basically, we don't know what resources or how much resources to allocate to each pod, because there are a lot of possibilities. So if you'd like to optimize it, we would run on another machine, Optimizer Studio. This is the tool. Optimizer Studio will run a workload script that basically will do 5 main things. It will first clean up the code, the environment, sorry. It will then apply the resource allocations to each pod and configure the cluster. It will then configure the PHP, Apache, and MySQL tunables, because we want to optimize them as well. It will invoke the load using Taurus. So Taurus will call upon the BlazeMeter servers, and they will apply the load to the Kubernetes cluster. They will take care of everything that is relating to the test, and eventually the Blazemeter servers will report back the result of the test and back to Taurus, and the script will get this result, calculate the cost of running the cluster with the result, and report back the result to Optimizer Studio, and this will run iteratively. So this is basically our testing environment. So let's look at the tunables that we're tuning. So we're tuning Kubernetes tunables of the number of CPUs per node and the amount of memory per node. And there is a formula to calculate the cost from Google. This is where these constants are taken from. And you just need to plug in those numbers, and then you know the cost per hour. And when configuring these, you basically have 2,000 possible configurations just for the memory and the CPUs. And here, this is per pod. To make things simple, we made sure to have the same configuration for the database and the web server, but this is not necessarily so. If you'd like it different, then it's 2,000 squared, which is 4 million. Apart of that, we have PHP tunables that add another 750 configurations. You have Apache web server, that's 15,000, and then you start going to the millions with MySQL. So if you multiply all of these, it turns out to be a very big number. It's 10 to the power of 17 configurations just for this setup, and this is why you cannot solve this problem using exhaustive search. You have to have some kind of smart algorithm to navigate through this huge space and find a good configuration. So these are basically the files that that we use. We have a script called run that invokes Optimizer Studio. Optimizer Studio invokes the workload script. It also gets the parameters of the tunables from another file named, we call it knobs.yaml. The workload script calls on Taurus, which has its own files that configure the test, and they call on Blazemeter. And we have the Kubernetes controller that is called from the workload script, and it has also its files that configure it, and the configuration files of the PHP and other application frameworks that are on the cluster, and it distributes the configuration files to them. So I want to show you. Zina, you want to step in?
Yeah, sure. So can you hear me?
Yes.
Okay, so this is just like as Tomer explained, this is a workload script. So the first one, if you see here, is the Optimizer Studio, which is our tool, and the next part is just setting, the way if you want to define like specific setting, which is already supported by Optimizer Studio. And the third part is the knobs. So the cube_knobs.yaml contains the Apache, PHP, and all including the Kubernetes tunable files. And the last one is a workload script. So inside the workload script, we are using these configuration files, and we are creating config map to which goes to eventually Kubernetes pods, and we are also invoking Taurus inside the workload.sh script. Okay, so this is the knob file. So you can see at the top we have like global settings, just how many samples.
Hey, Zina, just one question from the crowd. Can you increase the font size a little bit? Thanks.
Oh, sure. Okay, so this is the knob configuration file. So at the top, you can see just configuring the statistical behavior of Optimizer Studio. How many samples would you like to take from the baseline and from the configuration? The next part, the import section, is because Optimizer Studio already supports Apache, PHP, and MySQL knobs. You really don't have to do anything. You just have to supply the your configuration file. Apart from that, you just import these three application knobs out of the box, and you can just use it. So if you would like to define something which is not already supported in Optimizer Studio, for example, in this case, the Kubernetes knobs are not already embedded. So if you go down, if you see, like, if you look at like down there, we have another knob section. We have CPU knob. Like it starts from a minimum of 2 and it goes all the way to 16, and with step size of 2, that's for CPU. And we have also a memory knob for Kubernetes nodes. So this is a memory knob. So it means we have 2 Kubernetes knob here, and the top are just the one we are importing. So if, yep, so.
Yeah, so that's the knobs YAML. Maybe we can talk a bit about the workload script.
Right. So this is the workload script. So basically, it takes those configuration file from the knob file we have seen before, and it is going to use them to just run the workload. So this first section is just validating if the knob values are okay. After that, we just clean up everything we have previously. We delete all the deployments and the config map for the Kubernetes, which we already have. And then we create a new Kubernetes node. Basically, we are using node pool inside the cluster. So depending on the CPU and RAM memory size coming from the previous configuration file, we are going to create a custom node pool here. Then after that, we redeploy the Kubernetes pods again, because now we created a new node pool depending on those configuration, and now again we are deploying on the new node pools. So now we are good to go. We set everything. Now the next part is we want to run the Blazemeter test. So yep, so here you see here a Blazemeter load test using Taurus. So there is result equal to here we have like bzt, then taurus.yaml file, and we are just parsing the average time from whatever the output the Taurus is returning. And then we have the result, which in this case is average response time, and we have the cost. We multiply the node memory and the CPU, like Tomer explained, to find out what is the cost of the current resource we have. And then we combine them, the average response time and the cost, to find out per like million requests how much I'm paying with this configuration. So then finally we push the target metric to the temp.blazemeter blz result file, and then the node file will get it, and the optimization will continue from there.
Okay, and this gets of course there are other configuration files, and then basically we run it, and these are the results. So first we try to deploy this Kubernetes cluster, and we did not know the resources that we need to apply for each pod. And we had an option to take between 2 to 16 CPUs, and an option to take between 4 gigabytes to 64 gigabytes. So since we did not know anything, we chose as a baseline something in the middle, so 8 CPUs and 32 gigabytes. And then we ran the tool. It took roughly 3 hours to get to this result. And the tool found that we actually need, we try to optimize for cost, not for speed. the tool actually realized that we need only 4 CPUs and only roughly 13 gigabytes of memory. And since we are optimizing for cost, this is the important number. So the cost is reduced by 50%, and the speed is actually it's actually slower. But it makes sense because we want to minimize the cost. So the speed is reduced by 7%. So this is again the result of defining the target market, target metric only for cost. We then also looked at the result. This is not the second one. This is just looking at the result of the first one. So in this process, we searched for what has been the best performance in this journey to reduce the cost. And we found a configuration that actually you get wins from both sides. You get wins, you get a win for speed, and you pay a little bit, another 2% in cost. And you can see here the configuration. Then on top of that, we now ran the optimization that included PHP, Apache, and MySQL. And we were able to get even more savings, that's 53%, and almost wipe out the slowdown. So now the slowdown is 1%, and it's already within the noise. In conclusion, we are able to get a much lower cost cluster without paying anything in performance. Now, had we wanted to get more performance, we would have configured the tool just for performance, and we would have been able to see also a good result. So that's basically it. Before the questions, I will just say that if you would like to know more information, you're welcome to contact us. There's the email that you can contact us, or use the chat on the website. You can see our website here, BlazeMeter's website here. And if you use the promo code BM500, you will get a $500 discount on annual plans of Optimizer Studio. So happy to take questions.
Tomer, just before we go to the Q&A, and by the way, we have some really good questions from the audience here. Could you explain on what was the load that was generated? And I think maybe it wasn't explained well in the demo, but what did we generate on our environment, and what was the final configuration that we got per the same load?
Sure. So the load that was induced was a relatively low load to be able to use the free tier of BlazeMeter. I think it was around 20 virtual users accessing the Magento admin interface and doing all sorts of actions in that interface. So this was all possible with a free tier. And here we can see that eventually, choosing something in the middle in terms of resources was not that far from the optimal point in terms of resources. Here it's just much more detailed, too much detail to show in this webinar, but there were many tunables that were tuned in order to wipe out the slowness, the slowdown.
Thanks. And Emma, can we get some questions from the audience?
Hi, yes. So firstly, thank you everyone for joining us. We had quite a lot of questions coming in, so we'll try to get to as many as we can. I know in the back end, Raphael has been helping also answer some, but a lot of people have been asking about tuning for specific products. How can we know what we tune for? And for example, DB Oracle, MySQL, on Cassandra, TCP Stack, Mellanox. Nick, can you kind of elaborate on this? How can we support? What other things can we support?
So
now just coming in.
So let me get back to this slide. So basically, the Optimizer Studio has been used already to tune a wide variety of applications and systems It has been used to optimize web applications, optimize CPUs, CPU products, other embedded devices, mobile phones. It's just about anything that can use static tuning can be optimized by Optimizer Studio. Now, the idea is that if you look at a software installation, you need to look at your software stack. Now, if your software stack includes one of these, then it's very easy to plug in Optimizer Studio and start tuning. But even if you don't find the main things in your software stack in this list, you can always add your own. It's very easy to add new tunables, especially if you're an expert in the system that you are trying to tune. With set and get scripts or with the knob file that we have shown. And we can also assist in that. Like, for example, we are very soon will come out also with support from Cassandra, because you mentioned Cassandra. So if there is something that there is a pain point in the organization, we can certainly help to get users up to speed.
Great. So we had a question about earlier in the presentation. What's the name of the tool that was mentioned that you can use to replay a production workload?
Yeah. So you can do that with Blazemeter. So if we look at Blazemeter runs on top of Taurus. Taurus is the test automation tool. And Taurus support, you can go to gettaurus.org and see all the different engines and open source engines that Taurus support. We have customers that use JMeter for that. Actually, we wrote a blog a couple of years ago how to take, a small Ruby script and JMeter and kind of take Apache log and just replay it over and over again and control the speed of that. Other customers that we have using Gatling or Grinder to do the same thing. And basically, it's about which tool for load testing you're using today, do some minor adjustments, and then be able to replay your logs just like it was any other test. So it might require you to work with R&D as well to make the application aware of the fact that now we're going to replay logs. So for example, think about cookies, session IDs, those things that you sometimes need to put like a virtualized server to either mimic that, or some kind of an agreement on R&D that on staging with this session ID, we always going to be able to do those kind of things. And then you can do that. Another methodology to do that is sometimes you can do sort of a mirror of your application, and you can say, hey, every request from every, let's say 1% of my production queries are going to my database, but also they're going into this separate environment. This is a more tricky solution to implement. Also, regulation might come into place on that, but it's also a possibility to do those kind of things.
Hello? Okay. Can you hear me?
Yeah.
We can hear you.
Oh, sorry. All right, so we had a question as well about how would you automate memory leak tests or when optimizing memory for reporting at least one metric?
Good question on that. Memory leaks are tough to handle. Actually, Blazemeter and Concertio together can really help with that. With Blazemeter, you can run, for example, soak tests for maybe like 5 days to understand if you have a memory leak, right? Or just run a bunch load of server users against your microservice to see if they will behave accordingly. And once you found that memory leak, then you usually go, you can find it on your JVM, on your configuration of a database or something like that. Then you can use Concertio to literally fine tune it and run those tests over and over again. So you run like one huge test for, let's say, 5 days. You verified you have a memory leak. Now you can run a lot of subsets of that test faster to get the proper configuration for that. And Tomer, feel free to jump in. Like if you have a special case on memory link and how you can do that, that's great as well. But you can just focus on that and then run the soak test of that to validate that.
Okay.
Tomer, are you available? Yeah, just to add a little more thing on this. I mean, for some of experiments, especially when we were dealing, especially things like OpenMPI, we were dealing with the available resource on the cluster. So in the script, we can like consider the number of CPUs and the number of like the size of RAM which is available, and we can kick off from there, just like so that you can somehow avoid the burst depending on the available resource you have. So that might also help to avoid memory leak somehow.
All right. Thanks. Tomer, did you want to add anything, or should I go on to the next question? I know we're going to round up, so I'm going to do one more question, and then we will I will send out the questions to our host, and we'll try to answer as many as we can in the coming days as well as the recording that we'll be sending out in the coming days. So as a question, does this tool tell us what areas the optimizations addressed in terms of GC, EBS, EF context switching? And we also have another question. How did you set up workload, model, and production and stage environment?
Sure. So the first question is whether we get some insight. I would rephrase it. Do we get some insight after we run Optimizer Studio? So yeah, absolutely yes. You get the list of tunables that were tuned. And from that, you can generate insight and understand, yeah, these were memory tunables that helped, or these were networking tunables. For the second question, how do we set that up? So usually, we have the production environment, and in order to reproduce that in a testing environment, we need to set up a real testing environment that is on a smaller scale than the production environment, and try to mimic the load as much as possible. Of course, scale down for the number of servers that we need, but try to mimic the load in the infrastructure as much as possible. So if you're running on AWS, it's better to have your testing environment in AWS using the same kind of instances that you would use. Even the region is important, because sometimes the same kind of instance in different regions behaves differently. And really try to make it as similar as possible to production. And then once you have this staging environment, then you can connect it to your CI/CD pipeline. So every time that you make a commit or a major commit, then it can invoke the automated performance tests and automated functional tests. And once everything runs, then you can go to the automated optimization. And it can run on the staging environment. And when it finishes, the production, the output will be the settings that you can apply in production together with the new binaries that you have created. And you can either deploy them in the delayed manner, or you can do it speculatively by deploying the binary, and then when the optimization finishes, you just distribute the script that applies the changes to production.
Hey, Tomer, quick question. I see a lot of people are still asking about, can you guys do fine-tuning for Docker? Can you guys do for a Solarflare network interface card? If somebody has a question on how Concertio can help me tune something, where should they go to? Is there something on your web, or some kind of a guide that tells this how you can tell?
Sure. So our website has some information about what we have experience with, although it's not a complete list, but there is some information. I think what the easiest way is to go onto our website. We have a chat. Just start chatting with us, and we will respond and let you know. And about Docker, yeah, absolutely. We have done many tests and got good performance also with Docker.
So can you jump to the last slide so people can maybe take a print screen or something like that to get that? Also, there was the promo code there. And here we go.
And
Okay,
we hope to support Solarflare in the next few months. So if there is if someone is interested, you're welcome to chat with us.
Yeah, so just to add a little more thing on the Docker and other containers. So the best way is just instead of like tuning inside, the best approach is, I think, to have like a local configuration file and you just map it to the containers so that every time you run a studio, it will change the local configuration files. Then those files will be mapped to the containers or to the pods in Kubernetes, and it will use like the new optimized configuration files.
Super. And for those that still have questions or something or want to, regarding, for example, the Solarflare, you can see the contact Concertio at info@concertio.com. Good time to take a print screen of that so you can have that. And Emma, correct me if I'm wrong, we're going to share the recording with everybody?
Yes, we're going to be sharing the recording in the coming days, and I'll share also all of these links again, so you'll be able to have that as well. So yeah, just want to round up and say thank you to Tomer, Rafael, and Zina. Thank you all for attending today, and as always, we welcome your feedback, and if you can answer that quick survey, and we'll be sending out an email in the coming days with the recording. Hope you all have a great rest of the day, evening, and hope to see you at our next webinar. Take care, everyone.
Thank you.
Thank you, Emma.
Thank you.